Hi everyone, my name is Kuwat. Today I'm going to talk about Antarctic krill schooling response to different environmental stimuli cues such as flow, light, and algae levels in a test facility in the laboratory. Antarctic krill are an integral part of Southern Ocean. They form huge massive swarms called schools, which are organized, polarized, and their biomass is similar to that of humans. And they are main food source for uh, big animals such as seals, whales, penguins. There has been an effort to model their distribution in relation to environmental properties such as ocean current levels, upwelling, downwelling regions, and presence of predators and prey, so that we can model their distribution better, which will help us to manage Antarctic krill fishery better. So um, what we wanted to do is see their threshold responses under these different environmental cues. To do that, we have built an annular tank in the laboratory because doing experiments in the wild is difficult, if not impossible. And so in this annular tank with diameter of 1 meter, we expose Antarctic krill to different uh, flow levels, uh, light levels, and we have ability to uh, uh, incorporate algae and predators such as penguin guano. So the flow in the tank is varied in speed using this inner drum that rotates and outer tangential jet, and also we can adjust the light levels, and we have multiple cameras attached overhead the frame so that we can get their 3D positions at different trials uh, at different trials with combinations of these mainly three features. And um, one of the trials has no dark light condition, which means the all lights are turned off. It's completely dark. In that case, a camera cannot see Antarctic krill schooling, cannot see anything. So to accomplish this challenge, we have placed infrared backlighting underneath the tank so that cameras still can see the Antarctic krill while Antarctic krill are not affected by infrared lighting. We have performed different trials at different flow levels, light levels, and densities, where density here is number of krill at unit volume, per unit volume. And we have plotted organization level a parameter, which is OR here, rotation order parameter, where OR equals 1 corresponds to perfect milling around the center of the tank. And at around two densities, 1 and 9 krill per liter, we see that Antarctic krill school better than others at both bright light condition and dark light conditions. And we see that as we increase the flow levels, they school better at all densities. What distinguishes between A and B is that at no flow case, shown with a green curve, we see that at dark light there's no schooling at all densities. But they can school at bright light at no flow case, as shown with plot A, for example, at 9 krill per liter density. So this tells us that Antarctic krill may not initiate schooling at complete darkness, which means they rely on their visual cues, visual senses, to form into a school. We have different results, for example, log normal distribution plotted on top of histograms of speed and nearest neighbor distances. And we have other OR values for algae levels. These results can be discussed in the meeting in more detail. Thank you.